Very good. Did anybody get a weapon this time? There was one time where they had a Nerf, like, yeah. Oh, the air cannon. No, did anybody take that? Nobody takes that.
But it wasn't working.
I might have broken it. I was using it fairly aggressively on...
I don't want to know why.
Where's Dover?
That's a good question.
Very good question.
He was just in the...
Yeah.
Did he get diarrhea from the pizza? Real question is, what would Beyonce Prime turn into? Turns into a ring?
Or a box.
All right. Anybody else get anything? What was this? External drive?
Yeah.
What size?
Terabyte.
Oh, that's pretty good. It's USB 3?
No, I mean, it's powered USB too. So.
Yeah, but USB 3 is fast. So that's actually a good one.
If he hits me with that, I will kill him.
Any other good prizes?
SSD.
Okay. Yeah. What are you going to use it for? Actually,
Yes!
what size drive's in your ThinkPad?
500.
Oh, so it's an SSD.
I don't think this one is SSD.
Is that a newer ThinkPad or an old one?
It's a newer one.
Well, it would probably be. If it's only 500 and... It's got to be an SSD if it's the newer laptop.
28 gig flash drive, wasn't there?
Solid state, yeah, solid state drive.
No, there's flash drive.
Oh, was there?
There was only 64.
Yeah.
A couple years ago, I got.
Yeah, you could upgrade your laptop with the solid state.
28.
If it's a mechanical drive, but if it's a newer laptop, I would think it would not have a 512 gigabyte mechanical drive, and it would be a 1 terabyte or bigger.
Newer laptop.
Well, I mean, Amish, I guess, is anything. I mean, this thing is whittled out of wood, and then to get it to look dark color, they burnt it. They had to call in their Amish shaman. All right. Anything else? Anybody else get good stuff? I mean, everybody should have gotten something, right? Everybody attend?
Yeah. When I got that, it was over.
Marie?
He was Netflixing and not chilling.
I didn't even have a chance.
Maybe Levi was working on his 470 homework.
No, he was.
He wasn't.
Did you turn this one in?
Huh?
Did you turn this one in?
Yeah,
Oh, sweet. Did you get it right?
I think so.
Ah,
Otherwise, I wouldn't have turned it in.
I'm always excited when I go to grade Levi's assignments.
There's a 50-50 chance it's going to be right.
I mean, Levi's really smart. I mean, he's bright. Yeah, he's smart.
Yeah,
He doesn't always do everything, but he's smart. So, I mean, it would be, for those of you who are struggling, it might be a good idea for you to work with Levi, to encourage him to do his work. And then he would help you because he actually knows his stuff pretty well. He's bright.
when I do it.
So,
Right, that's it. That's
he knows
it.
But he's lazy.
Yes.
I don't even know it's lazy. He might actually have just strange, my guess actually, he does have strange priorities, would be my guess. That's not laziness. That's just like, hey, I have other things to do and I'm an adult, I'm going to do them. So there's nothing wrong with that except it hurt your grade, but whatever. You know, he's a big boy. So I don't know, I like Levi. I'm always excited, like, oh, did he do this one or not? Because I can use it as the answer key. Okay. So homework was to expand our environment to support the storage of lambda expressions, right? Okay. Specifically, the production 2, or I guess we're losing out on that. It may be production 3 now. Did we say that production 1 is a lit expression, production 2 is a var expression, production 3 is a lambda expression, production 4 is an app expression? Let's say that's right. All right. How many of you did I already just lose? All right, perfect.
I was lost before I came to class.
All right, so I want to put a couple things in context here. I was talking about this at the beginning of the get-together thing. There seems to be some confusion as to why we would want to store a lambda expression inside of an environment. All right, so let's. I'm actually going to go. Let's go over here to Java here, and let me actually let's just close these things. We'll assume these are all working chunks of code. Okay, so here is my program. We're looking at Java because we all feel more comfortable, confident with Java than we do with Scheme. Scheme is very scary and gives us bathroom problems, all that stuff. All right, so these were text messages from Beyonce Prime. So integrated. I've integrated Beyonce Prime into the vernacular now. We're good. It's now canon, right? All right. So when we're working with Java, this would be what we would call a program, right? Okay. And when a program is first born, wouldn't you agree that an empty environment is created to store the stuff having to do with that program? Got to have it somewhere, right? There's got to be a starting point. We definitely have variable environments. We've talked about scope and stuff like that inside our Java program, so it's not like this is stuff we've made up for Scheme, right? Okay, so we have an empty environment that gets associated with our program, public class driver. Now, that empty environment could be extended here with our global vars, right? We could have some global variables up there. We could have, static int blah is equal to 5. So that would extend the empty environment with a new variable named blah whose value is 5. Right? What other things extend that environment? All of these methods. So let's just look at this display method as an example. That guy right there that I have highlighted is a lambda expression. That is, it takes in this case, one parameter, which happens to be in an integer array. So that's its parameter list. That's the arguments. And here's the body of that guy, all the stuff that he does. Now, in this environment, the environment that we've extended with this one variable here, we've also now extended with another variable named display, whose value is the lambda expression associated with that function. It's an untapped resource until we call it. But we have added it to the environment so that up here, when we say display, it has to go and look that up somewhere. It has to go and resolve that somewhere. What is this an example of? Right here. What's that guy? It's an app expression. I'm applying this function to this value. Syntax is a little bit different in Java than it is in Scheme or our made-up language that we're creating. But it's the same thing. These aren't foreign concepts. These are things that you've dealt with all along. We're just having trouble making those connections. So why would we want to have an environment that can store, why would we want to have a variable environment that can store things beyond just integers? Well, because sometimes we need to store things that aren't just integers. Well, what else do we need to store? Well, we store strings, we store other objects, we store methods. Sometimes we take that for granted, right? We don't necessarily think of methods as being similar to variables, but they are. What's a variable? It's a name-value pair. We have the name of a method, and the value of the method is a lambda expression. Make sense? That's the reason that we are adding to our environment the ability to store lambda expressions. That's why when we learned about methods originally, way back when, we talk about this as being an untapped resource. We've written it, but until we call it in the context of an app expression, it's never being used. We're writing it, we're throwing it into the environment, it's available to us, but until we actually call upon it, it's useless. Okay? So, now, we want to think about our variable environments. Let's try to give some context to our variable environments here. So our var env. This is a collection of name value pairs. That's what that guy is. Collection of name value pairs. We need to consider what are the different types of values that we have. Right now in our language, we have numbers are values. So let's say values are numbers. And we have decided we want to add lambdas as potential values. Things that we can then apply to parameters. Now, when we were talking at the beginning of the get-together today, and I was talking about basically what we're talking about right here, what types of things does an environment that supports storing functions represent? Somebody said that it would be, I think it was maybe Dover, who said that it would be how functions are first-class objects in Scheme. What does it mean for a function to be a first-class object in Scheme? Mentioned this a long time ago. We've seen it in action a bunch of times. Go ahead. Okay, pass it as parameters. First-class objects can be passed as parameters. Functions be one of these. Be one of, that's not going to let me do that. Be one of these. Close enough. Okay, most bestest. So, that's what functions are. Is being able to store a function in a variable environment an example of functions being first-class objects? An example of a function being a first-class object would mean that we would need to be able to pass a function as a parameter to itself, or to something else like itself, to other functions, right? Where would first-class objects exist? When we think about our lambda calculus productions, LC expressions, we have lit expressions, we have var expressions, we have lambda expressions, and we have app expressions. Parameters exist, well, parameter lists exist here, right? New envs are created here. So anytime we have a function, we have a parameter list and a new environment that will be created. Where is an example of objects as first-class expressions, or functions being first-class objects potentially going to be in this world here? Is it going to be in lit expressions? Do you have diarrhea from the pizza?
I messaged you. I had to pick my sister.
So why are you out of breath?
Because I ran from my car to here.
Did you really read so much?
I did. It's 99% sure.
Oh, it's on Slack?
Yeah.
Okay. We didn't have a quiz. You're fine.
They even show up.
So, would we find lambdas as first-class objects in lit expressions? What would we find in lit expressions? Numbers, literals. So, if we expand our definition where it might go, maybe we find chars in there. String literals maybe at some point. That type of stuff. Maybe we have list literals at some point. But right now, numbers. Okay, so certainly not there. What about var expressions? What do we find in var expressions? 100% of the time, what does a var expression look like? It's like a symbol. It's a variable name, that's it. Now, we might do something with that variable name. If we know it's a var expression, we that clues us in that we need to resolve this guy before he's usable. Okay, but in terms of how he looks, he's just a symbol. What about app expressions? Would it be true that the only place that a function could be passed as an input into another function would be in an app expression? Because that's the only place where we provide the inputs that are associated with the expected parameters of a function. What's an app expression? An app expression is function params, where one of these params could potentially be a function. Would that be an example of a function as a first-class object being passed in as an input to another function? Is that useful? Can we do that in Java? Does Java allow us to pass in functions as parameters to functions?
Some languages do.
Absolutely true. So Scheme is one of them. Hopefully everybody in here could honestly say some languages do. Because Scheme does.
Well,
Okay. Java does not.
currently.
Whatever. So Java does not. Those of you who are taking the Swift class, yeah, Swift has closures. You can pass functions in as parameters to a function. So this isn't unheard of, right? But understand that adding the ability for functions to be stored in an environment has nothing to do with whether or not functions could be passed in as parameters to other functions. Storing functions as a variable inside the environment provides the ability to call an app expression. When I call this app expression and I have a var expression, for instance, in this case, a variable named display, display needs to be resolved. In this case, we have a requirement that display boils down to a function, right? That's what app expressions take. We just had it in this slide right here. App expressions is a function followed by parameters. So, we're going to have to check to see what it boils down to. But any way you cut it, we're going to go and look up in our environment the value associated with display. And what are we going to yank out of there? We're going to yank out of a lambda for this guy. And then we're going to take that lambda and we're going to parse it, which then makes it executable. Okay, so one of the hints I gave last class is you might choose, when storing stuff in variable environments, to not evaluate the values. Because not everything is evaluatable. I think that's, evaluatable. Not everything is evaluatable. What does it mean to evaluate a lambda expression? What does a lambda expression in and of itself boil down to? So here, if lambda scares you, what does that right there boil down to? In and of itself. That's all. Your entire world exists in what I have highlighted there. What's the input? No, specifically, what's the input? Well, it's an integer array, but what's the name of it? What is it? If I'm line 1, I'm right here. I'm trying to evaluate this guy. So I'm sitting here. What's the value of AR? I'm trying to evaluate this lambda expression because what I have highlighted here, this is exactly a lambda expression, right? This is not an app expression yet. This is a lambda expression. This is an untapped resource. All we're looking at here is a lambda expression. We don't know. We can't evaluate this. AR, we hope eventually one day will have a value, but until somebody's actually given us a value through an app expression, I cannot boil down, I cannot evaluate a lambda expression. Lambda expressions they can't be evaluated outside of the context of an app expression. We have to marry a lambda expression to its parameters in order to evaluate it. Make sense? So, if we cannot evaluate lambda expressions without context, without them being inside of an app expression, and I'm telling you we should be expanding our variable environment to support the storage of lambda expressions. That's what we store in Java, right? We don't store things like this. That's an app expression. What you want to do with your lambdas is completely your own business. Okay, we're going to let you store them. That was kind of a weird sideways knock on you there. It was a euphemism.
Did you get my picture of the goat yesterday?
Christian worldview. What's this?
Did you get my picture?
You said you found him on campus. Where on campus?
There was some event going on. There was a goat's butt right there.
Why did you focus in on that part? Never mind.
I'd tell you, but it's not appropriate.
All right, so if we need to somehow store the value of a lambda expression inside of a variable environment, we either need to treat lambdas differently or choose that we're not going to evaluate anything. And both of those have side effect. All right, so one option we can have. So let's think about this at the high level. Storing in an env. Right now, our environment supports us to store lit expressions and us to store var expressions. Correct? Both of these can be evaluated. Lit expressions boil down to a lit. Oh, here, we'll do the little arrow thing. These guys boil down to a literal. Var expressions boil down to, as far as our world exists before this homework assignment, var expressions ultimately boil down to literals, right? After they've been evaluated, their value is revealed, right? So we had a placeholder A, which ultimately was the number 5. Okay, so once we evaluate it, we get the 5. Now, we're being asked to be able to store lambda expressions in there. And we just had that discussion about evaluating lambda expressions doesn't make sense. We don't know what the input will be, therefore we can't evaluate it without context. And we don't have that context, but we're just trying to store it in a variable. So what we're really trying to do, we have a bicycle that could be ridden. All right? So we don't break the bicycle down and we don't evaluate the bicycle. We throw it in the garage so it's there when we need to ride it, right? That's what we do with bicycles. Same thing. What do we do with lambda expressions? We throw it into the garage for when we need it. We can retrieve it from the garage and then use an app expression to put somebody on the bike. That makes sense? So at the very least, lambda expressions cannot be boiled down. So these guys can't be evaluated. So at the very least, we need to store them in terms of their structure so they can be applied later. Make sense? So now we have a decision to make. Do we choose to not evaluate anything? So if we're adding literals, do we store them structurally? If we're adding variables, do we store them structurally? Or do we choose to not evaluate lambdas and store them as is and store the evaluated versions of lits and vars? What's the trade-off?
I don't like trade-offs.
I want you to think about this through the lens of a programming language. When are we putting things into a variable environment? Let's look at this from a Java perspective. Oh, let's do it. So we're going to say int a is equal to 5. All right. Now in our little world, this is going to actually create what? A var expression, var exp, a, and 5. That's the structure it creates for us, correct? Okay. Well, there's double quotes around the bar, whatever. Good enough. Okay. Actually, this would be a lit expression. Yeah, so lit expr 5. That's what it actually creates. Okay? So now, we could store that entire thing inside of our variable environment, or we can choose to just store a and 5. Or we can choose to store a and lit expression 5. So 3 options. So what do we store? Do we store a is equal to 5? Do we store a is equal to lit expression 5? Do we store, actually that's probably the only ones that make sense. Only those 2 make sense.
Wouldn't it'll always be a var expression first? Because it's
Correct. Yeah, that's why this is the only way that makes sense. All right, so now let's keep going down the line. So now we're going to say int b is equal to a. What does this create for us? This creates a var expression, b, and setting it equal to a var expression, a. So now our choices are we can store b is equal to 5, which involves us actually resolving this value. Or we can say b is equal to a var expression a.
It's not right. We're not creating a pointer.
Hold on, this is not even a pointer.
It's essential.
It's a delayed evaluation.
Pseudo.
It's a delayed evaluation. So let's see where it breaks. Let's see where it breaks. So now I'm going to say system.out.println a. And then I'll say system.out.println b. What kind of animal is this? These guys? These guys right here. What kind of animals are these? From our lambda calculus expression world. These lit expressions, var expressions, lambda expressions, are app expressions. These are app expressions. We are applying a function, println, to these parameters. A, function, println, to these parameters. B, these are app expressions. Everybody see that? These would make excellent quiz questions. If I write some Java code and say, what kind of things are these in the lambda calculus world? It's not difficult. Right? You just got to get your mind wrapped around this stuff. We're so intimidated by the word calculus and lambda and the curly and the parenthesis diarrhea stuff, okay, that our world is ending when we're looking at these things. These are app expressions. We're applying a lambda, this guy.
Can we have that quiz, like, not next week, but the week after when I'm on morphine?
We'll have it both times.
Compare the answers.
All right, so these are app expressions. So what will print out here? When I try to print out the value of a, what's the value of a? Value of a is 5. What will print out here? The value of b. Value of b is 5. Regardless of how I represent a will be 5 right here. Regardless of how I represent b will be 5 right here, correct? Either choice I make. Now I'm going to say a++. A++, this effectively updates our environment to change the value of A, correct? It doesn't add a new variable A to our environment. It updates the existing value associated with A. So A is no longer 5, A is now 6. Fair enough? What will print out here? 6. Depends. If I stored B this way, it would print out a 5. And that's what should print out in Java, right? A 5. This change in A has no impact on B up here. I set B equal to the original value of A. All right? But if I had implemented B this way, or my environment this way, and I stored the unparsed version of A, the var expression version of A, B does not get resolved until we've actually asked for its value. And right here, we're asking for the value of B. And what's the value of B in our environment? It's the var expression associated with A that gets resolved to 6 in this case. So would we say that if we're using Java as our template, that this would be the correct way to store things in our environment? This would be incorrect because now it's based on when we use the value. When I create a variable B and I set it equal to A, I don't want it linked to A forever and ever, amen. Christian won't be. Okay. I want it what? I want it to have the current value of A. And for any changes to A from this point forward to have no impact on this whatsoever, right? So by definition, we need to evaluate that expression. And the good news for us is it is evaluatable. Yeah, I like it. That sounds weird, but I think it's right. So lit expressions, we can evaluate, and we should. Var expressions, we can evaluate, and we should. We just proved why.
Evaluable.
Evaluable? Really?
Able to be evaluated.
It's evaluable.
All
Able to be evaluated.
right. Evaluable. Evaluable. Huh, that's weird.
5 times fast.
All right, so we see why that's important, correct? But now we've also, because we don't want to break logic. This would break logic if we stored it this way, correct?
I like working logic.
If I set B equal, well, it would. Because now we're at the mercy of what have we done to A up here before we actually use B.
It's essentially a pseudo pointer.
Well, it is a pseudo pointer, I guess. I mean, I suppose that's true.
We could just
Except if A's address changed, B would still be linked to it.
correct.
Yeah.
So that's why it's
Yeah.
pseudo. It's not.
All right, so we've decided that we always need to evaluate this. We always need to evaluate this. Otherwise, it doesn't work like Java works. And we're going to say that the way variables work in Java seem to be time tested, right? Variables work in Java the same way as they worked in C++, the same way they worked in C, the same way they work in Objective-C, the same way they work in Swift. Variables have kind of found their home in terms of how we should apply programming logic to them, right? All right. When we define something that can be evaluated, it should evaluate right then and there, and then that's the value from that point forward. Pointers, well, they evaluate to their memory address. So both of those guys point to the same place in memory, great. So as long as they're both pointing to the same place, any value that's there should be, that should have permanent changes for both of them. But if one of those guys points someplace else, now they're no longer linked. That's the way it should work. That's the way our variables work, okay? So we need to evaluate lit expressions. We need to evaluate var expressions as we're putting them into our environment. But we've already said we can't evaluate lambda expressions. It's not possible. They can only be evaluated in the context of an app expression. Does that make sense? All right. So our current environment, as we have it now, it allows us to put lit expressions in there, and it evaluates them, correct? Sure, I think so. Can't I say A equals 5 in the current?
the equivalent of A equals 5.
Yeah, in our app expression, when we're expanding it, won't the app expression be app expression with some lambda, and then we'll have lit expression 5, something like that? And that lit expression then gets evaluated. Don't we map eval expression across those lit expressions to give us our 5? And then we pass into our extend E and V for a lambda guy. We pass at the A, we pass at the 5, the evaluated 5, right? So we can store lit expressions in there, but post-evaluation, post-evaluated lit expressions. So we're storing a 5 in there. They also support variable expressions now. Why? Because we're evaluating them. We're getting the current value of the variable and storing that in our environment. So our environment already works for these two in that exact same way. No changes whatsoever. All we need to do here is we need to treat our lambda expressions as special cases. If we see a lambda expression and that if we see something we're trying to store in our environment and that something is a lambda expression, don't try to evaluate it. The worlds will break. Does that make sense? Store it as its structure. Store it as its unparsed version. Now when we pull something out, we can look at it and say, are you a lambda? Are you a lambda expression? If you are, I need to apply you to something else in order for you to make sense. You're not evaluatable. Evaluable. Is evaluatable wrong? Or is just the correct way of saying
It
It
sounds
sounds
every time.
Yeah.
Evaluatable, not.
I think it's more better.
That might be the correct.
All right. So does this make sense? So now, what are we going to do? Go into our code here. And this guy currently works, right? Currently does something.
Maybe.
Am I passing? Oh, I'm passing it broken stuff here. Yeah, I'm trying to pass it in. The parameter to this guy is a lambda. So let's, for starters, was it? You said a pound sign?
Semicolon.
Semicolon? There we go. Nailed it. All right, so let's go ahead and let's try to extend our environment with a lambda. Something bad will happen? Yeah, okay. Go ahead, Josh.
For the and expression, are you supposed to pass it 2 things and you're only passing it 1? Or no? No, you're
I'm passing it the lambda and the 5. All right, so first we need to see how our environment can work holding lambdas. Okay, so we're going to say define E and V. This guy will start off as the empty E and V. All right, so now we have an environment. All right, now we're going to expand that environment with a scope. Okay, so let's go ahead and let's define scope to be the empty scope. Okay, now I want to add some stuff to my scope. How do I extend a scope? To extend a scope using our current thing, we extend it with var-val pairs. So I'm going to give it, let's just say A is 5, along with the current scope. Oop. So we'll say, this might be a decent time to show you this.
Oh boy.
Set bang scope to be extend scope A5 scope.
What?
What magic are you doing?
Setting it to a.
Oh, sorry, this needs to be that guy. So there's our scope. Set bang is how we update a variable.
Setback. Pretty good.
So I can redefine scope if I want. But it's telling me this name has previously been used. So I want to change the name of that variable. So we do that using setBang. That updates the current variable environment in Scheme to change the value of scope to this new value. Does that make sense? Now, this wouldn't have really helped you in your functions up to this point, because setBang is external from that. What's the equivalent to setBang inside of your, well, actually, we don't really have equivalents to setBang, but how do we handle variables that we want to exist inside of our lambdas? Through lets. Okay, and at this point, we've introduced lets, but not let star and let rex, just lets.
Let Rex.
I think he told us about let star, but I don't know
Okay.
if we officially added it to
All
our
right.
It is.
scheme.
Well, I'll ask a quiz next time on both of those. Like, you guys are going to get zeros on them anyways. It doesn't really matter what the question is.
We don't get zeros if we put our name on it.
What's up?
So we don't get zeros if we're here.
Remember if I took that pill.
Don't wanna-
That's right, 30%. What do we got?
Uh,
There's muscle relaxants, or
no, I took one of those before I came. to
so?
class.
What are these?
This is like a really strong anti-inflammatory. Like a
That's not
1.5
going to do anything for me.
It's got a little bit.
Look at the size of a rhinoceros.
Take half the bottle.
Is that the movie Armageddon where the NASA's doing the tests on the guys, and they have the really big the really big black guy from the Green Mile. Yeah, and he's like, one of these guys, tested positive for a very powerful horse tranquilizer. Some of these guys are pretty big dudes. It was like what he took instead of Tylenol. Like, I have a little headache. What's bad is I think he took the suppository orally.
Whoa.
Christian worldview. All right. Okay, so setBang allows us to update a variable in our environment. So we're using Scheme's environment thing here, okay? So we're going to change scope to be whatever's returned by extend scope A5 on scope. Okay, and that guy gave us this. All right, now we're going to go ahead and we're going to say setBang scope to be extend scope B, and now we want to pass it the structure of a lambda. All right, so we're going to pass it the list. It starts off as a lambda. Yep, I'm faking it here, right? We're just using our environment before we actually go in and make a few changes in our code to support this. We just want to see what it's going to ultimately look like.
So you just basically parse the lambda expression.
I'm not even going to parse it. I'm going to pass it in the unparsed version.
Wouldn't that just be lambda then?
I get it. I'm not going to evaluate it. I'm passing it in the parsed version.
Oh, yes.
The string and symbol version, not the constructor version. Yes, the parsed version. I meant the we're not going to evaluate it. The unevaluatable, most bestest thingy majiggy. Beyonce Prime. Brought to you by Nabisco. All right. All right, so lambda expression, and then it takes in a parameter list, right? So just, I don't know, we'll say something like A there, or something like that. And then it takes in a body. And let's just say the body is A. So something like that. Is that what our lambda expression would look like in a list? Oh, then at the end, yeah, at the end of this guy, we have to add our scope. Okay, but this is the correct parsed version of a lambda expression. Is that what it looks like? Actually, it's not. It looks like this. This guy is a var expression. Like that. So it's a list whose car is lambda expression, whose catter is the list containing expected parameters, and whose CADDR is the list containing, well, is the body, which is a lambda calculus expression. All right, so this is a legitimate lambda expression right here. So now we're adding to our scope the variable b associated with a parsed version, a parsed but not evaluated version of a lambda calculus expression because we can't evaluate a lambda calculus expression. By the way, a great quiz question might be, why can't we evaluate a lambda calculus expression? Which is what we spent 10 minutes talking about a little bit ago.
You don't know the parameters.
Yeah, you don't have parameter values, so you have no context to evaluate it, and you need an app expression to evaluate it.
Well,
All right.
If you pass in a lambda without parameters, then can you evaluate it? If there's no parameters.
Lambdas require parameters. You can have 0 parameters, but it requires a parameter list.
But it, 0 parameters.
Oh, I understand what you're saying. If it's not expecting parameters, can you evaluate it?
Right. Because I'm pretty sure in Java and Swift and most other languages you can pass in.
Well, I mean, the answer is still...
You can evaluate.
so let's go back to this. Can you evaluate it if it takes no parameters? Possibly. Should you evaluate? The answer is still solidly no. Because the only time the only time we actually evaluate a lambda is in the context of an app expression.
Oh yeah.
Yeah, we have to pass it. If it takes no parameters, we pass it no parameters, but in the context of an app expression. All right, so now we should be able to type in scope. Whoop. Did I run this? I don't remember if I ran this. Let's run it. Now we should be able to type in scope, and there is our list containing a scope whose first value is a b, whose value is this, and whose second value is the list A. Second scope, rather. Shouldn't it be?
That's right. You put the A's in for the lambda expression, which is kind of messy.
Oh, it's just looking funny. Okay, yeah, that's right. Okay, so if I made this something, if I made it other than A, it wouldn't confuse us. But whatever. Here's the second guy. A is equal to 5. All right. So our environment, as it stands right now, is capable of holding the parsed version, the parsed but unevaluated version of a lambda expression. We just need to make sure that we don't try to evaluate it first. Where are we trying to evaluate it? We're trying to evaluate it up here where we have our map guy. So this guy right here, we're mapping onto the app expression. So this is when we're in our app expression, right? So if we're in our app expression and the car is a lambda, so we're only going to try to do this if we actually have a lambda, okay? But we're kind of making the argument right now that that's really the only time that app expressions in our understanding exist, right? First value must be a function in our world right now. You know, we're kind of making the syntax work down here, but we really could assume that this guy would be a lambda expression if we wanted to. Because it's all that makes sense. Does any other app expression make sense? Probably not. Okay, so we could change this, but let's not change too much right now. All right, so this is when we're extending our environment. Here is the parameters. These guys right here. Okay, that's going to be the list of parameters. And what are we doing? We are mapping this lambda onto that. And what does this lambda say? It says whatever lambda calculus expression comes in here. That's what that's going to be, is a lambda calculus expression, right? So we have a list of parameters. Each one of them is a lambda calculus expression. Every single one of those guys is going to be a lambda calculus expression. And what are we doing with it? We're evaluating it in the current environment. But, so this already works for lit expressions. This already works for var expressions. What if I passed in a lambda expression? It breaks, right? Because we can't evaluate a lambda expression. So all I have to do here is change my map to throw an if in here. If car x, let me actually kick this down before life ends. Is equivalent to lambda exp. Is that what it is? That guy? Looks like that. Then boil down to x. Else eval the expression.
Would it be cleaner to just have written a helper class and then map to the helper class? calls eval.
Well, you mean write the helper function instead of inline the function here?
Yeah.
Yeah, probably, but since this is the only place we ever use it, yeah, I mean, then we might say you have just like this random function sitting out here, and what the heck is this for? So
Well, if it has eval,
what makes the most
helper,
sense?
then-
What makes the most sense here would be to use a letrec, which allows us to define functions, which we don't know about yet, but that would keep it self-contained. Let's not make it any worse than it already is. All right, so now what are we doing? We're mapping this function. That's an entire function right there. It's a function that takes a single parameter and asks a question of that parameter. It says, if the car is a lambda expression, don't do anything to it. Just return it. That'll keep our lambdas unevaluated. Okay? Otherwise, go ahead and evaluate it in the current environment. Does that make sense? So all we've done is changed our little map there. And now we should be able to store lambda calculus expressions inside of our environment. So we come down here, get rid of this. All right, so the problem is when we run the program, it's still going to break, but it's going to break for an okay reason because we don't know how to apply lambda expressions yet. So right now we have a function, that guy right there. This is an app expression. So an expression right now is an app expression whose first parameter is a function. That's good, right? Our app expressions allow for functions, for lambda expressions to come first. Perfect. This is an expression that takes in you know what, this might work. Let's see. I don't remember who wrote this one part the way I think we wrote it. I think it might work. So this guy's this is a lambda that takes in two parameters, and what does it do? It builds an app expression out of those two parameters. That is, it applies this function, assuming a is a function, to the value of b, which in this case is 5. Well, we'll find out. You mean up here where I fixed the map? I should, because I think I wrote everything inside the map. It looks pretty good just because we have a lot of parentheses.
Should that finish out eval expression though?
No, because you need to pass
That's past everything out though.
So the eval expression, we're going to evaluate this expression in the environment that is that, so you're right, it should.
Because that's the first part of the if
Yeah.
statement.
Well, so let's just make sure that
the valid expression need the environment?
this will be the environment, the result of
Oh, yeah,
extend
yeah.
env for lambda. All right, so that's the end of that if. That's what we do with the true. This is what we do for the false. That's the end of the if. Here is the list that we're applying it to. There is the... Oh, wait, no. Yeah, it's right here. We need to end our lambda there. There we go. So that's our self-contained lambda right here. So we added in the if's right there. Here's the end of our lambda. We're mapping that lambda onto the list of parameters here. So that's the end of our map. So this is going to boil down to a list of potentially evaluated guys. What are we going to do? We're going to extend our environment with, let's see, what's this guy? That's the list of variable parameters with the list of values and the environment that we're extending it with. And then we're going to evaluate the expression in that environment. Yeah, we were just missing one parenthesis for the new if that we put in there. That guy. Okay, so in our app expression, we're taking, this is a function that takes in two parameters and creates an app expression, right? Where we apply the first parameter to the second parameter. And what parameters am I passing in? Parameter 1 is a lambda expression that takes in an x and boils down to an x. So this will be a var expression, correct? And what is 5? Well, 5 is b in this case. So what should the output of this be? It's going to take in A and B, so that's going to take in our lambda and a 5. We're going to apply that lambda to our 5. Here's the lambda. 5 comes in for x. We print out x, so this should boil down to 5.
Where it's like pink. There. Yeah, that was a problem.
Well, yeah, I was wondering whether this was going to actually evaluate it, but our environment definitely supports.
All the homework was right. On to make it work.
So what's happening is you're passing at one point through the program, you're passing that list app expression list bar, that line there that your cursor was over.
Mm-hmm.
You're passing that to a val expression, and so it's going through the car of that list, trying to match it up with something, but it doesn't find app expression.
Oh, because it's finding
So
this.
anything. No, it's looking for app expression at the very front of that line.
It should be the else.
And so it's looking for the car of LCE, which is giving it an app expression. So it gets down to
All right,
the
so
bottom.
let's just walk through this. Let's walk through how it's working through this.
It's just getting to the list of the list.
So we're calling a val expression on this guy. Okay, so this is our parsed code, right? All right, so very first thing we run into is an app expression. So we get to our else here. Here's our app expression. We're looking at the car of this is the lambda expression, so we're good there. So now we're going to get into the eval expression of the body, correct? So this is list ref LCE1. So this is 0. This is LCE. Let's see. Oh, bucket 2. So that's going to give us our body. That's this guy right here. Does this guy give us highlights? Oh, that would be awesome if it did that. Okay, so we have list ref of LCE1. This is our entire LCE right here. Bucket 1 of that is this whole thing. That. Bucket 2 of that is this is 0, this is 1, it's this guy right here. So we're evaluating that expression, okay, our app expression, inside of the environment created by getting our list AB, so that's our parameter list, and mapping this function across the CADDR of LCE. So that's the first codr, this guy. The second codr is this guy. The car of that is this guy. No, this guy. Actually, it's this. No, that would be the car. The car will be this. No. Car will be this. It's that. So CADDR of that guy will be this list, whose first element is a lambda expression and whose second element is a lit expression. All right, and what's this guy going to do? He's going to map our function across that. And what does this function say? It says if the car of...
Isn't the car of the footer though one into it? So
Well, no, so it's going to map across it. So the first time through, it's going to be looking at this.
Yeah.
The car of that is lambda-exp. So since that's true, we're just going to go ahead and boil down to the value. So we'll boil down to this, just x. Otherwise, so the second time through, our second map will come across on this guy. That's the second map. So we'll evaluate our lit expression to give us a 5. All right, so this should give us our extended environment with our, this guy here, should give us our extended environment with our lambda and the other guy in there. And then what are we doing with it? We're calling eval expression on the body of this with the rest of it. So what I want to see is I want to see what this guy looks like. All right, I'm gonna cheat.
You can do the debug and just hit click next about 400.
Oh, will it let us do that?
Yeah.
The debugger is pretty. I like
Hit
it.
out a bunch of times to get. You can step through it all, or you can just hit out and it kind of gets you through stuff. It's gonna take you a long time.
Where does it show me what my?
Right side under variables. You just gonna keep going for a long time.
Okay. So we currently have. Oh, this is parsing? Can we put breakpoints?
Just hit out a bunch of times. So you can try. It should get you keep going. I don't know if we can actually.
All right, so that's our lambda AB with our lambda. Okay, so that is. How do I do a breakpoint? Oh, maybe that? Is that a breakpoint?
I don't know what you do.
So let's just get into this guy here. Ah, pause at this point.
Right click it and a context menu will.
Yeah, I did it already.
Too slow.
All right, so here we go. It would be nice if this wrapped. All right, so this is what this guy currently looks like. So we have our app expression, whose first element is that, whose second element is whose body is an app expression, var expression A. Okay, so this is the first time. So now I'm going to go, and it'll stop here again. Okay, good. So now we have this. We have an environment whose value of B is 5, and whose value of A is this lambda expression. So it looks like that got created correctly, right? So our environment was extended correctly. So that's the homework assignment. And then the lambda calculus expression right now is our app expression where we're applying A, which is our lambda expression, to the list containing B. Is that maybe where we break? So let's step here. So it was looking for, yeah, we did not get into, we're in the list part. We're in that second version. It didn't think we were dealing with a lambda.
No, because you have app expression there. So then it's going to try and grab the car of LCE because it thinks that there must be like another list.
Oh, we
inside
haven't
of
resolved
lambda.
it. We have to resolve the car.
So you're just going to end up with LCE equaling app expression, and then you're going to try and take the car of that, and at which point it breaks.
Yeah. So that means that in a situation like this, where the body of our app expression is actually another app expression, we need, oh, this is not a big deal. We're just assuming it's a lambda.
Yeah.
We need to now be able to handle app expressions in here.
Right.
So that's okay. So else, if we're looking at a lambda, do one thing. Otherwise, let me just stop this.
Sit like enter somewhere.
Okay. I did hit stop. So we need to stop our breakpoint. Okay. So now, right here, this is the stuff we do if we're dealing with a lambda as our first element. Well, it's not the first element. It's the 0 element of the first element. Yeah, we're still good. App expression. Man, I wish we still had the other screen up. Here, we can still do this. Close.
You need to do the debugger.
Yeah, you hit run, not
Oh.
debug.
And
There it is.
I need to go one more time. Okay. Oh, I think you were saying the right thing. I was understanding a different thing. It's looking for that to be a lambda. It's looking for the car of that to be a lambda, but it's finding var expression. So what we need to do is we need to resolve that guy to a lambda and then do it. So if we find a var expression there, which is our other type, we know it's got to be a lambda, but it might be a lambda hidden in a var.
But we're already looking for var expression.
No, but not inside of an app expression.
Oh, yeah.
Yep. So we can do this. We're out at 25, right?
Mm-hmm.
All right, plenty of time.
That's what he said.
All right. So if I probably want to change this to a cond. Actually, what we probably want to do is we probably want to take this list thing out because I said we no longer need this. I just need to press enter somewhere. I said, right? All right, so this is our else. I'm scared, Sarge. All right, so this is our else for this guy because this ends right here, correct? If that's true, do that. Otherwise, we can assume we're dealing with a var expression. The car of that guy is a var expression. That means that this guy is a var expression. It was the word var expression. And what do we do with that? It is this guy that's the actual var expression, correct? And what do we do to a var expressions? We call eval expression on them. So we're going to go ahead and call eval expr or exp on that guy in the current environment. So this should resolve this guy down to that lambda. Then what are we going to do? Then we're going to eval exp on that lambda, passing it this guy. And now this is where it might have been handy to put it in another. This is where we were.
Just maybe.
Oh man.
Passing it that. So we're evaluating the expression in the environment that is. What? I copied that.
It
No, you
said
didn't.
no.
That's not selected.
Oh, I just thought it was selected.
Because it highlights it.
You just put it in a stop. You're still missing the thing.
No, I think we're okay. So I'm going to evaluate that that lambda that comes out from that in the environment that is extended with the. Make sure we get this right. So this is the. Yeah, this will be the parameters, right? So this is the actual lambda expression. That's the list of it. This is the parameter list of that. Then we're going to map this function across its except we can't say CADDR of LCE. We need to say two. That'll get us the list, bucket 2 of it. This is saying, give me the lambda expression then give me element 2 of that lambda expression, which should be the list of values. And we're going to be evaluating that expression there. Okay.
No, didn't like that.
Which index was too large?
Index 2.
Says it looks like this. Okay. Well, we'll finish making this work next time, but the homework assignment, all the homework assignment was to fix that map.
But you said
No, doesn't matter.
Right here.
extend ENV for lambda, which you never touched.
Oh, which is fine. So you could have still passed in evaluated functions into extend ENV for lambda. You could have changed this to always not evaluate, then change extend ENV for lambda and say that if something comes in that's not evaluated, if it's a lit or a var, evaluate it there and leave lambdas alone. Or you just fix this. You can do it here, you can do it there, but if you're going to do it there, you have to undo what you were doing here.
Well, I didn't do anything. 'Cause it already works.
Yeah, I did. No, I'm going to.
Because you're passing in a list of variables and a list of bars, or a list of bars and a list of variables. So the way it's working already is
Well, it wouldn't have.
pairs them.
If you map eval expression
But it's
across,
not mapping.
what's not mapping?
It's extending ENV for
I don't
lambda.
know, ask Evan. He probably
The method isn't mapping.
Oh, okay, I get what you're saying. Assuming that you passed in the right kind of values to your extend ENV for lambda, it does what it needs to do regardless of what those values are.
Yeah, it's good.
Yeah. So as long as if you pass it a lambda, however it got that
Yeah, as
lambda,
long as you're passing a
Fair enough.
two lists, sitting pairs.
that's fair enough. Yeah. So technically, you could make an argument that you didn't have to change the code at all.
Yeah, which is
No, you could, because he's saying since I asked him to change the extend ENV for lambda, extend ENV for lambda could literally take in any kind of value and just make it work.
yeah. It just,
Technically.
it just
How it got
pairs-
its value is
It just pairs the parts of the two lists together.